these videos are up that he can use. Hi. You all good? Okay. All right, you said 23? Carmen, you said 23? Awesome. All right. We will get there. Okay. Okay, if I take a look at number 23. 23 said, I have k minus 8 over 7 plus k is equal to negative 1 over 5. Is this the one you're talking about? Awesome. Can you see that okay?
Yeah.
Okay. All right, so always use cross multiplication to solve proportions. All right, so I have to do 5 times a quantity of k minus 8 equals negative 1 times a quantity of 7 plus k. The biggest mistake that I see is that people forget to put the parentheses. I'm not saying in here, I'm saying in my experience. People forget to put the parentheses on, and they simply do 5 times k and not that 5 times 8 as well. All right, this is an expression in the numerator and an expression in the denominator. You have to kind of like, those parentheses are like implied. All right, so you need them for the distributive property. All right, so I end up with 5k minus 40 is equal to negative 7 plus a negative 1k, or negative k. Are you cool with that so far? Okay, so now we have an equation with variables on both sides. So you have 4 different ways you can start this. All right, I've told you guys this, I like getting rid of doing my variable terms first and making them positive. That's just me. So I end up adding a 1k to both sides. So I have 6k minus 40 is equal to negative 7. All right, I'm going to do adding the opposite here. So I end up having to add a positive 40 to both sides. And I get 6k is equal to 33. Did I do that right? 47, yeah, 33. Divide each side by 6, and k is equal to, so because these were fractions, your answer has to be in fraction form. That's Mrs. Carter's rules. I don't know what the answer was, but that's what I'm saying. All right, so when I divide 33 by 6, that divides into it 5 times. So I have 5 and 3/6, which simplifies to 5 and 1/2, and it is positive. Are you good with that? Sweet. L? You did? Okay. Are there any other things I can do for you guys? You guys pretty good with these? Okay, put this away, get your notes out. Okay. So we're stepping away from solving equations right now. We're stepping away from proportions. All right, and we're going to be talking about rewriting equations and formulas. I just did this with my other class. All right, so today is the 18th. We are doing Chapter 2, Section 8. All right, and the topic of this is rewrite equations and formulas. All right, there are things called literal equations. Literal equations. These are not new to you. You've used these quite a bit. Some of them you've seen before. Some of them you probably haven't. All right. Literal equations are any equation with more than one variable. What we are going to be doing is we're going to be focusing on they can be formulas, or they can be a generic, the way that we're going to be doing it first. They're going to be a generic format of an equation that we are using, that we use. All right, that's very vague, but you'll understand when I get to one of these. Okay. All right, so let's just jump into an example of what I'm talking about. So here is an example. All right. Well, let's give examples of what these might look like. An example of one could be ax plus by equals c. That could be a literal equation. This is just a general format. We could have one that's a minus by equals c. All right. We could have formulas. Area is equal to 1/2 base times height. That's considered a literal formula, a literal equation. It's a formula. So these first two are just examples of generic format equations. And it could look like anything. All variables. All right, that last one is considered a formula. All right, so let's dive into what we're going to do with these, okay? So what I want you to do is I want you to solve ax plus b equals c. So there is our literal equation. That's just a generic format of an equation. I want us to solve it for x. All right, that's the first thing I'm going to do. Then what I want you to do is then use the solution to solve 2x plus 5 equals 11. So this is a funky, I know you guys could just solve that anyway, all right, but we want you guys to be able to, it's like a puzzle. We want you to be able to look at equations in different ways and how we can use them to solve these generic equations to solve actual equations. All right, so let's work on this first part. So this is solve for x in our generic equation. ax plus b equals c. All right, you're probably thinking to yourself, why in the heck are we doing this? Okay, do you guys ever use Excel spreadsheets? You guys ever use an Excel spreadsheet? Okay, what have you used it for? What have you used an Excel spreadsheet for? Rafaela? How? Okay, and how, what are you doing in Excel to make a table? Explain to me what that means. Okay, so so I think that if you guys have a column for volume, right, that you input, a volume for mass that you input, right, and then you have your column for density, right, and there's a formula that uses volume and mass to find density. Does that sound right? Okay, so in an Excel spreadsheet, the cool thing about that is that in that column for your density, you can input a formula for it, and then you copy and paste that formula all the way down in that one column, right? So then you can put in a variety of volumes and masses, and it will automatically, very quickly do all of their densities, right? So that's how spreadsheets work, right? I want you guys thinking about that as our use here. So let's say, and I'm going to use the example of volume of like the area of like a triangle, okay? I want to find, if I know the area of a triangle and I know the length of it, I want to, and I'm changing those two things, I want to find out all the possible widths, right? Base times height, 1/2 base times height. I know the area, the height, I want to find various bases. So instead of me giving you this area and this height, and you find the base, this area, this height, you find the base over and over, I can use an Excel spreadsheet, I can solve the area equation. Area equals 1/2 base times height for height, right? Without any numbers in it, other than a half, I could solve it for height. I could have a column that has that formula in it for height, and then I'm simply just inputting areas and lengths. And I could put in 5 or 6 or 10 of them, and it will into my spreadsheet, and it will automatically do my calculation for me. Can you guys see how that would work? That's why we're learning how to do this, okay? How to rearrange equations. Does that make sense to you guys? Okay. I'd like to try and give you an idea of why we are doing things, so you're not just doing things because you think we're mean. Okay? So, I want to solve for x. So, pretend that a, b, and c are numbers. I know they're not, but just visualize that they are. For me to solve for x, I need to get ax alone first, correct? All right, so how am I going to get ax alone? L? Yep, I'm going to subtract b from both sides. Now, I recognize I can't do c minus b, but I can certainly write it out, can't I? So I have ax equals c minus b. Remember, I want to get x alone. All right. How do I get x alone now? Rafaela? Divide both sides by a. So I'm just going to divide the whole thing on that right side by a. My a's divide out, and I get x is equal to c minus b over a. Are you guys cool so far with that first part to this? Okay, so now we're going to do the second part. So here's the first part, here's our second part. I want to use this because I could give you a whole bunch of this format. This is the original format that we had. I could give you a whole bunch of these equations with this format. And now what I could do is, you now have an equation here that allows me to solve all of these without individually subtracting 5 divided by 2. Subtracting, if I had these numbers were different. If like 3x plus 5 equals 20, I could solve that with this equation. All right, so I'm going to rewrite this. So I have ax plus b equals c is the format. Our equation was 2x plus 5 equals 11. All right, we reformatted or solved this equation, and we got x is equal to b minus c over a. All right, we want to solve this equation using our transformed equation. So, that 2 lines up with our a, 5 lines up with our b, the 11 lines up with our c. Can you guys see that? So now what I'm going to do is I'm just going to substitute this a value, this b value, and the c value into our new equation. So x is equal to b, which is 5, minus c, which is 11, divided by a, which is 2. So I end up with, it's a negative, this is going to be a negative 6 over 2, so x equals a negative 3. Yes, what did I do wrong? Is it c minus b? Thank you for correcting me. So 11 minus 5. So that's going to be a positive 6 and then a positive 3. You guys cool with that? So I could have given you 5 or 6 of these equations that actually has the numbers in them. And you could quickly solve for x, for all 3 of them very quickly, by just using this transformed equation. You guys cool so far? All right, let me give you guys another one. So I want you to solve the literal equation for x, and then use the solution, or that new equation, to solve. All right, and I'll put a colon here because I'll put both of them down there. All right, so my first one is going to be ax equals bx x plus c. That's my literal equation. And the actual equation is 11x plus 6x plus equals 6x plus 20. So 11x equals 6x plus 20. Go ahead and do this, please. Hi, sweetheart. Of course. A calculator?
Yeah.
You are more than welcome to use one of mine if you prefer, but you certainly can go to your locker if you'd like to. Okay. So I have ax equals bx plus c. Help me solve for x. How many of you guys are kind of struggling solving for x? Okay, let me give you a tip, and I'm going to let you keep going. Get both x terms on the same side. And then I want you to think distributive property. Or distributive property in reverse. So try it again. Get both x terms on the same side. And then I want you to think about distributive property in reverse. See if you can figure it out. Talk to somebody. Carmen, you're more than welcome to come down and sit with these guys if you want to, or try and figure out on your own. All of you, whatever you'd like to do. You can turn around if you want. All right. So get both x terms on the same side, and then think the distributive property in reverse. How many of you guys have ax minus bx equals c? You guys cool with that? Okay. So when I say to you, you can say that if you want. If I say to you, use distributive property in reverse, on that left side, what do you think that means I'm telling you to do? Natalie? Not on the second equation. The first equation, that literal equation, you are solving that literal one that only has variables in it for x. So you right now are looking at ax minus bx equals c. So looking at that, tell me. How many of you guys agree with her? If I did the distributive property in reverse, that x comes out, right? That's the common factor. Absolutely, that's exactly what it is. So x times the quantity of a minus b equals c. Nice job. Now what am I going to do? I need to get x alone. It's tempting to do the distributive property, isn't it? All right, if I had this for you, you guys know I like my sticky notes. If I had x times 3 is equal to 9, what would you do to get the x alone? I know that's not usually the order we see it in, but Lily, what do we normally do? Yeah, I'm going to divide 3 from both sides. How many of you guys are cool with that? Okay. Well, what's x being multiplied by here? What's x being multiplied by here? Ashley? Can I just divide by a minus b? Sure, absolutely. I'm just going to divide by that quantity of a minus b. I can do that. There's no reason I can't. It's still a number once I know a and b, right? So that binomial, that's what those are called. When we get to the end of the year, we'll talk more about polynomials, but that binomial, two terms being multiplied, they cancel each other out. So I have x is equal to c over A minus B. Questions on how I did that? All right, so now I'm going to use that for 11x is equal to 6x plus 20. So I need to identify A, B, and C in this equation from my literal equation. What's my A, what's my B, and what's my C in this equation? I'm comparing this and this. It might be easier to see in what I wrote here. What's my A, what's my B, and what's my C? L? Excellent. So now I'm just going to substitute those in. So A, oh not A, this should say X, because we're solving for X. So X is equal to C is 20 minus, or divided by A, which is 11, minus 6, which was B. So I have 20 over 5, so X equals 4. Yeah. You can't, because you have not solved for X. The directions are solve this for X. So I have to solve that for X completely, and then I'm going to use it on this equation. So if you don't solve for X completely, because you're not sure what to do, right? But then you're like, but I know what A, B, and C are with this. I'll just put A, B, and C into that, and I'll be fine, or into that, and I'll be fine. You will get marked down for not finishing solving the original equation for X, but then I'll give you credit for doing that. You know what I mean? The goal here is I want you solving for X, and then using it. Maggie. Oh, that's always like alarms in my head when someone says that. Go ahead. You divided by A minus B. No, you can't divide by something when you have them both in the same term. You've got to pull it out. Sweet. Thank you. Excellent. Thank you very much. So what you're saying is if I get to this part right here, is this what you're saying? Yeah. That I'm going to divide by A minus B. Yeah. Nope. No, you cannot do that. The only way you can do that is by pulling that out, because there's no factor of A minus B here. You have to do this first, so you have that factor of A minus B. Does that make sense to you? Sweet. Okay, are you cool with that, you guys, so far? Okay. So now let's look at when we have just regular old formulas. You're going to like these a lot better. Or regular old equations. Okay. We will do more of this type of thing when we start looking at different types of linear equations. So now what I want you to do is I want you to write, okay, y as a function of x. This phrase we're going to talk about a lot when we get into linear equations, specifically slope-intercept form. Okay? What this means is that we're going to have an equation that says y equals, and there's some math with x in it. So it's y equals and then math with some x in it. An example of that might be y equals 3x plus 4. So that's what y as a function of x means. That means write an equation y equals something with our variable x in it. Are you guys cool with what that phrase means? Okay. So what I want you guys to do is, I want you to write 3x plus 2y equals 8. So that y is a function of x. So write 3x plus 2y equals 8, so that y is a function of x. So when I'm done, I went y equals. All right, so let's figure out how I'm going to do that. So I have 3x plus 2y equals 8. I want to get y alone. What do I have to get alone first before I can get y alone? What do I have to get alone first before I can get y alone? Because right now I cannot get y alone. Maggie? Yeah, I need to get the 2y alone first. How am I going to get my 2y alone? This process is exactly the same as if this said 3 plus 2y equals 8, right? Getting that y alone. So how am I going to get my 2y alone first? Molly? Excellent. I'm going to add negative 3x to both sides. So I have 2y is equal to 8 plus a negative 3x. Now what? Remember, I want to get the y alone. Now what? L? Divide both sides by 2. I'm just going to divide the whole thing by 2. I lied. Divide them individually by 2. I want to set you guys up for when we get to slope-intercept form. Divide both of them by 2. Now, I can divide out common factors if possible with these individual fractions. So my 2's divide out, and I'm left with y equals. Well, in that 8 divided by 8 over 2, that ends up being a 4. So I have 4 minus 3 halves times x. You guys cool with that? I mean, you might not like it, but are you good with it? L. Okay, I would always divide them individually. So when you have this problem, instead of doing it all over 2, you're dividing each number individually by 2. That's the same thing, right? So if I have this, if I have 1/2 plus 3 halves, how do I add fractions? You guys, up here. How do I add fractions? I know this is very rudimentary for you, but the idea of it is what I'm trying to get at. How do I add fractions? Oh, this needs to be a yeah, that's right. How do I add fractions, Ryan? And we keep the denominators, right? So this really is 1 plus 3 over 2. How many of you guys agree with that? So these two things are the same thing, aren't they? So I want you guys to look at this because I want you to understand that 8 plus a negative 3x over 2 is the same thing as 8 over 2 plus negative 3x over 2. Those are the same thing. All right. L, how do you know to do that? The one thing I will say to you, L, is that 8's divisible by 2. Can you guys see the 8's divisible by 2? That automatically tells me I'm going to have them be separate fractions. Okay? If that was like a 9, you may have left it as one big fraction. However, when we get into slope-intercept form, you are going to be having individual fractions there. So I want to set you up for just doing that no matter what. So when we're doing these, instead of dividing them, both of them like this, I want you dividing them individually. So do that all the time. So then there's not a decision to be made. Does that make sense? Okay. So let me give you guys another one. Yes? I could turn that into 1 1/2. That would be the same thing. Slope-intercept form, and when we get to it, if you turned it into 1 1/2, I would absolutely give that to you. That's perfectly fine. When we get to linear equations, which is, I think, might be the next chapter or pretty close to it, that coefficient of our x, you don't want it as a mixed number. You want it as either a regular fraction or an improper fraction, which is why I'm just going to tell you, leave it as an improper fraction, because that's where we're going. Does that make sense? Okay. All right, so I want you guys to, solve 5x plus 4y equals 20. so that y is a function of x. So all of you do this one, please. What should I do first? Carmen, go ahead, sweetie.
So you subtract 5x, and we'll add negative 5x to each side.
Excellent. So I have 4y equals 20 minus 5x, or plus a negative 5x. Go ahead, sweetheart.
Divide each one by 4.
So what's y equal to?
Y equals 5 plus negative 5, 4.
Excellent. How many of you guys got that? Awesome. You guys cool with that? I have one more thing to show you. I know this is a lot. All right, these are just different variations of kind of similar things. All right, so let's look at formulas. All right, so what I want you to do, I'm going to show you a triangle. So normally I do my ruler, but I'm not going to do that right now. There we go. All right, here's my height because it's perpendicular with my base. My base is 14 meters. All right, so what I want you to do is I want you to solve the area of a triangle. Formula for h. So I want you to do that right now. So what's the area of a formula for a triangle? Rita? No. Oh, yeah. 1/2. I didn't hear the 1/2 part. 1/2 base times height. Okay, here's the deal. What do you notice the base and the height are being multiplied by? Don't start. Just listen for a second. Because depending on the formula, you're going to do different things. All right, what is height being multiplied by? 1/2 times base. Okay? If this was, I'm going to do this over here. If this was circumference is equal to 2 times pi times r, right? That's circumference of a circle. And I wanted you to solve for r. I would divide both sides by 2 pi. So r is equal to circumference divided by 2 pi. Write that down. I know we're not using that right now, but I want to show that to you to compare it to this one. Does that make sense to you guys? I want to compare them. We're using this one, but I want to compare it to something else. In the circumference one, we have an integer times pi times r, right? So it's super easy to divide that 2 pi r by both 2 and pi, because they both divide out at the same time. Now, what I highly advise against is dividing both sides by 1/2 base. Isn't that funky looking? Don't do that. What I want you to do instead is, what can I multiply 1/2 by? Let's get rid of that 1/2 first. What can I multiply 1/2 by to get rid of it? What can I multiply 1/2 by to get rid of it? Ryan? 2 over 1. So I'm going to multiply both sides by 2 over 1 first, because that's a fraction. I don't want to divide by fractions. So when I do that, the 1/2 and the 2 over 1 cancel each other out, and I get 2a is equal to bh. Now, how do I get h alone? Rafaela? Divide by b. So h is equal to 2 times my area over base. So the last thing I want you to do is, using the new formula, find the height when area is 64.4 meters squared. So I want you to use that. So I'm just going to substitute what I know in. I know now that my area is 64.4. Well, they told us that the base is 14. When I do that, what do I get for my height, Giselle?
9.2 meters.
Yep, 9.2 meters. Now, again, you're thinking to yourself, why in the heck am I doing this? All right, the literal equation ones, I'd love to tell you why you're doing it and when you have a use for that. Maybe when you get into like electrical engineering or mechanical engineering, one of those professions where you're doing a lot with engineering and you have those generic equations and you're gonna, it's like a puzzle. It's like a Rubik's Cube. You're training your brain to do it. These you'll use a lot. These are your spreadsheet ones. So if you're ever designing anything and you know the constraints of the area of a triangle, you know the constraints of the length of it, what are the possible values for my height, right? This would be a spreadsheet situation, right, where you solve it, you put that formula in, and then you would just start putting random areas and bases in to find out what the possible height could be. Does that make sense to you guys? Oh. That's a really good question. What happened to our 2? We just didn't put it in. I didn't write it in. You all put it in there. I did not. That's why it happened to the 2. I left it off, Al. Okay? Thank you. I always want you guys correcting me. My brain is thinking ahead of time, and I'm not thinking a lot of times of what I'm doing. So thank you for correcting me. Are you guys cool with that? Awesome. You guys can go.